Hello, everyone. Welcome to this webinar where we are going to discuss some interesting details about how we are going to model non-trivial business models inside of a document database. I had quite a few webinars previously that talk about how we can model in general inside of RavenDB and inside of document database in general, but I wanted to have a deeper dive into a specific scenario, and hopefully that would allow us to tease us some of the more interesting details of how you build non-trivial applications using RavenDB. As usual, we have the Q&A button at the bottom. Feel free to ask any question at any time. I would much rather have this as a dialogue versus me talking to the screen for quite a while. I'm spending enough time talking to the screen as it is. So, without further ado, let's start. So, the first thing that we have to remember is how and what do we actually model? The traditional, almost the default approach of modeling things is still based around relational databases. You have a ERD, entity relationship diagram. It's based on tables and rows and columns. If you have a non-trivial environment, well, that just makes things more interesting. Because if I have users, and users may have hobbies, well, how do I represent something like that? In a relational database, I need 3 tables. With a document database, well, it's just right there. Let's see the difference. We have users table. We have hobbies tables. We have users to hobbies versus something like this. Now, this particular aspect, this idea of this difference between this one and this one, stands at the heart of the difference in modeling concerns. Because we have something called the impedance mismatch. How do I present something like that in my code? Something like this. Which gives me one-to-one mapping between this one and this one. If I want to translate this in a distinct, that is a significant amount of work. Now, this is the surface level. This is the most obvious difference between the two options. When we start talking about modeling concerns in the document database, we realize that this one-to-one mapping is awesome. It frees me from so many complications. And that means that my objects can be as complex as necessary. I don't have to adapt my domain model to the persistent format. But it only goes up to a certain point. Let's look at another type of issue. And here we see the other side. Because in the relational format, this is translated to this. What's going to happen here? Well, here's an interesting observation. A document database provides zero help in this regard. if I would try to do something like that, I would end up with this completely nested value. That's probably not what I want to do. So let's talk about this in more depth. It's very easy to model when we have one-to-one. It gets complex when I don't want one-to-one, I want something else. So how would I look into something like this? Well, this is not an embedded value. I want it to be some reference to another document. And here, when we designed RavenDB, and that was, dear God, almost 12, 13 years ago, there was a very conscious design decision. This is not supported. In RavenDB, every time that you have an object, it is always embedded. Technically speaking, we could have done something like this. Or if you're familiar with Hibernate and how it works, I could have done this and intercepted the call to manager get manager, and injected the value on the fly. This is how object relational mappers work. And I have worked with object relational mappers. I have built many of them for a very long time. And I'm very, very familiar with the downside of this particular approach. So I decided to avoid this entirely. And the downside, by the way, is that now you have a trap inside your system. Either one of those is going to be a nasty problem for you down the line. Why is that? Because accessing a property on a domain object would trigger a hidden, unknown to you, database call. So RavenDB has support for doing that using includes and reducing that, but reducing the number of network calls that you make and all sorts of stuff like that. But at the end of the day, we make it simple by saying this is not supported. And we want you to write it like this. Now, this sounds like a big limit, but it turns out there's been some thought behind that. And there is an interesting book called Domain-Driven Design. It's this nice book. And it was written quite some time ago, and it had a major, major influence on the design of how people model non-trivial object models. And one of the rules that are laid out in this book is the notion of aggregate roots, entities, and value types. What do I mean by this? An entity is something that has an ID. A value type is a value. What does it mean? It means that the number 5 is a value, but that's easy. A monetary amount, so $100 is a value. It doesn't matter. It doesn't have a meaning on its own, only when it is attached to something. Great. But entities has an ID. But aggregate roots is where we go and define the access points into my domain. And the only reason that domain-driven design and Evans had to create the notion of entities was that they're working with relational databases and they couldn't model stuff like that. They have to create multiple tables. In a document database, we have just this: aggregate roots and value types. And one of the interesting rules for domain-driven design is that you may not reference an interior object. If you have order, which is the order aggregate root, and order lines, which is an entity inside that, you may not reference a particular order line, only the parent order. And the reason for that in terms of modeling is that this is the scope of operations. This is scope for rules, this is scope for consistency, this is where everything happens. There is an exact match between that and RavenDB documents. So every one of your documents is an aggregate root. And references between them are to another aggregate root, and we want to make that boundary explicit, which is really important when you think about how you operate on your model. So now let's talk about what happened when we move beyond a single document. And I want to give you an interesting story. Quite some time ago, there was a document database. I will spare the suspense, it was RavenDB. And a customer used that to store a product catalog. And it wasn't a small one, it was an interesting one. And they called me and they were quite upset because RavenDB was so slow. Now, I'm looking at that and said, okay, what's the problem? And I checked into that and I was, wow. They were using RavenDB as a document database, singular. The entire product catalog was a single document, something like 1.7 gigabyte in size. I was actually shocked that it worked at all, not just slow. But after we talked to the customer, we told them, hey, you can store multiple documents inside of RavenDB. And then came the interesting bit. How do you break apart this product catalog into something that's more interesting? And this is the exact topic that I want to talk about today. So that's it. So the first thing that we have to understand is we need to define what is the boundary between the documents. When should I have an aggregate root? When should I have a distinct aggregate root? And when should I have just a value type inside of that? And I like to think about aggregate roots and documents as they have a reason to change. That's the scope of all of the business rules. That's the item around which we serialize all access. And let me give you a particular example. The order example, the online order example, is the most done example in the world. But we keep coming back to that because it's actually a good one to express without going into too much complexity. So what do I have? I have order, I have line items, payments, shipping, and billing, and a whole bunch of other stuff, customer, whatever. Those are the fields that I have. Now, a line item in this context is owned by the parent order. The level of business rules around this are at the level of the order. So all of those are in here. And we can think about many different business rules. For example, if you order more than 5 items, an order size greater than $100, free shipping. Okay, that sounds like a relatively straightforward rule, right? Well, think about what it means in terms of processing in a serial fashion. I want and I require all changes to this document to be processed serially, one after another. Why is that? Because if I allow 2 threads to modify the number of line items, I may miss out on this rule. Each one of them would operate independently. For each one of them, the result will be correct, but not in conjunction. So documents allow, or the notion of documents modeling allow us to modify just one at a time. We can do that through optimistic concurrency or through some other means that we discuss later. I mentioned that the notion of order has been done to the death. So I want to give you something new. Instead of doing the personal model, let's do a B2B one, which is a far more complex scenario. In the personal model, there is a single order. The scope of the order is limited. If I'm going to the store, a supermarket, and going crazy before a major holiday, I would have dozens, hundreds of items in my cart. But that's about it. I'm not going to have tens of thousands. I can validate that there is known single person who is driving that. So it's okay to serialize everything, which is actually a good idea to run the business rules as soon as possible to provide immediate feedback. If I'm modeling something like that inside of RavenDB, I want to use a single document for this purpose. But what happens when I'm working on a B2B concept? What now? Well, the fourth thing that pops to mind is that an order is not coming from a single location. An order may come from multiple locations all at once. I may be letting each manager order the things that they need. So the order can be modified in parallel. And all of my business rules aren't actually known at the time that I'm making the operations. Only when I'm actually moving the order from one stage to the next do I get to apply the business rules, which is actually a really interesting concept if you think about that, because this is a notion that I don't actually know what's going on. Now, I may want to provide some feedback based on local context, but until I'm actually running that operation, until I'm charging that order and moving it forward, I don't have I don't have the option of running all of the business rules. And that leads us to a really interesting situation. I have multiple documents, and all of them together compose a single whole. Think about that. Instead of having a single document for the entire order, I have multiple. Probably one for every entity that can modify this, because I still want to do the serial fashion for each user that adds to this order. But I'm not even trying to validate the entire order. Maybe I would do that as a MapReduce so you can see some details, but this is not intended to be, okay, well done. This is intended to see the state. Another aspect here that is interesting is that this also allows me to deal quite nicely with really large systems. Let's go back here to the notion of the product catalog. I have, let's say, 15,000 items in my catalog. And they're divided into categories, they're divided into property that they have or something like that. How do I break it down? Well, the natural thing in a product catalog is to have a document per product. And maybe also a document per category. And then we have to consider, where do we actually store the association? Can a product belong to multiple categories? So those are all sorts of interesting business questions. But the whole idea is that we want to split things up until we get to the point where a document has a single reason to change. And at the same time, we don't want to split things up to the point where where a document doesn't make sense in isolation, which is very common if we're talking about relational databases, where we have to aggregate data from multiple tables in order to make sense of what's going on. A document should be standalone and be able to operate normally. So now, let's talk about how do we model the big order. In this case, the scenario that we have is a big supermarket chain and a food provider. So at this point, we are actually standing to build a system for the food provider. And we sell things like milk, cheese, ice cream, and probably a whole bunch of other milk-based products. We have a standing contract with multiple different shops. Now, a shop may be a grocery store at Elm Street, or it can be a huge supermarket chain that ships to many, many branches and logistics centers and stuff like that. If I'm dealing with a single store, with a grocery store, probably relatively easy. I can use a single document, not really think about it. Let's focus what happens when my model is much more complex. Every branch can order things, and headquarters can also order things. And I'm shipping on a daily basis to multiple locations. The actual invoicing is an after the fact. So think about the number of concurrent operations that are actually happening here. How would you sit down and model this? What would be the core concepts? An interesting way to think about that is to say, okay, let's shut down the power. There are no computers. You're now operating solely through words written on paper, sent over physical mail. I was about to say physical email, and I'm quite amused with myself. So if we are operating with no computers and letters sent over snail mail, how would you build the business process? We're not even talking about how I'm modeling the documents or the data structures. So let's look at what we have. We have location that is a recipient of shipping. We have items quantities that will order for a location. We need to track all of the shipments, all of the receipts by that particular location. We have to handle returns and issue invoice and all of those sort of things. Now, let's go back up again and see what we have. Who can change what and where? A single location can have multiple people that order things to it. I may have multiple trucks shipping things. How do I think about it? What's the scope for processing all of this? And the answer starts when we talk about actual physical documents. We have this notion of a purchase request, which is a document. For each branch, for each authorized person inside that branch, they have the authority to order. And what they do is they are adding items to ship to the open order. And the structure looks something like this. We have a purchase request for a particular date, and this is for a particular person at a particular location. And they add as many items as they want, and there is no attempt whatsoever to be consistent between purchasing requests made by different people for the same location. Instead, what happens is that we may validate some rules in here. Oh, you want to add 10 tons of, I don't know, milk powder to this factory? Sure, we have that. Or sorry, 10 tons is too big to go next week. You have to order that 2 months in advance, whatever. Business rules that apply to that scope. But at some point, I have a cutoff. And this cutoff basically closes the purchase request for that particular time frame. And what it does, it says, okay, now all items that you want to order cannot be now ordered for this date. They must be ordered for next business day or whatever. So we open a new purchase request that they can start adding things to. And now I have a chance to actually run the business process. Now I have, basically, I have created a line in the sand where, okay, you have this free-for-all where you modify and you did everything and whatever. And now I'm, at some point, I'm doing the switchover. You can even think about it as a compare and swap operation. You have the open order, I'm moving it to the side and give you a new one, anything that you want will go down. And at that point, I can now apply all of my business rules, all of the things that I need to do. Decide, oh, I'm shipping it from this location, from that location. I'm arranging that to multiple different shipment orders, things like that. Something important in this model, by the way, is that how do you handle violation of business rules? In the personal order, what we typically do, we just do validation. If it's failed to validate, we stop the process. We show it to the user. In this model, we cannot do that. Why is that? Because the time that the user actually worked on this and the time that we discover that there is actually a problem are two different times. Let's say that we do this at midnight. When we discover stuff is wrong, sorry about that. That's going to, I'm not going to call it, hey, fix that at 2 in the morning. Instead, I'm going to generate a rejection document and have it sent to all of the people that needs to be aware of. Sorry, no milk today, the butler ran away and stuff like that. Let's look at the actual model. And there are lots of things going on here, so I would go over them in detail. Here is the ordering system. Notice that we have many purchasing requests going on at once for different things. Here is one manager for branch 23. Here's another one. And we basically throw everything together into this. At some point, we start processing that and turn it into shipments from different storage locations to all of the actual destination that we need to send it to. And we compute the daily charges. Eventually, we generate an invoice, etc. Why do we have multiple shipments? Why model it like that? Because the moment that I'm shipping something, a big truck or something like that, I'm shipping it over to the destination. Everything inside that becomes a document, but may have multiple. This is the shipping manifest, this document. And I may have multiple trucks that are leaving. I want to be able to track them separately and remember the rule. One reason to change. So the way that I'm doing that is each one of them get their own document, their own shipping manifest. One reason to change. And now you can see how it looks like in terms of actual documents. Let's think about that. There are a couple of interesting things that we want to look at. First of all, you can see that the concept of dates is really important in this sort of model. And I embed that explicitly into the document IDs, both because it really helps me to see what's going on, and because of the impact that it has on my design, because this is how I build things. Okay, so here all of the purchasing requests that I had for yesterday, and at some point I closed them and started processing all of that. Now think about how much simpler my life is now, because I can now process all of those closed operations. I'm very happy about that. And now I can create multiple shipments, update the charges, and eventually I'm going to issue an invoice. Suddenly this task of managing this multitude of complexity has been broken down into manageable levels. And let's talk about concurrency. I mentioned several times that the way that I'm operating is serial on a per document layer. So I want to serialize the access to a particular document. How does this work? Well, there are two ways inside of RavenDB that you can do that. In the first option, you can specify, I want optimistic concurrency. What does it mean, optimistic concurrency? It means that whenever the document changes, I have a value that I can look up. This is called a change vector inside of RavenDB. And let's see such an example. Now you can see here is the change vector. A173 and some random number. Now I'm going to do something interesting. I'm going to say this is now 16. This is now 20. And now getting this error. I expected this to be the change vector, but it was this carry thing. What's going on? Well, what's going on is that when we think about documents, I modify separate fields, modify the freight here and the quantity here. But the document is a single item. I don't have a way of saying whatever changing one field or the other is able to stand up independently. I have to do something more complex. So I don't do that. I treat the entire thing as a single unit. It makes sense. And with optimistic concurrency, I get to say any change that I'm making on top of this version. And if the version has been modified behind my back, I get to throw. I get a concurrency exception and I have to restart from scratch, revalidate all of my business rules, etc. This is a very important aspect. And this is off by default. That's something to remember with RavenDB. You have to explicitly say, I want to run with, it goes like this, session advanced. You have to do something like that, either at the session or on the store level. We also have the notion of cluster-wide transactions, at which point RavenDB will take over and manage that for you and detect that whatever documents have been changed behind our back. But the whole thing ends up being just one after the other. We do not allow concurrency here to maintain consistency and valid state at all times. A nice trick here, by the way, is the notion that we have a cutoff. This is where it has for all of those purchase requests. some point, this stopped being valid, and we throw that out. Let's talk about another interesting detail. What happened? We have hierarchies. We have the Cloud9 Superstore, and we have all of these hierarchy of stores. Here is Portugal and Lisbon and Spain, all of the stores in there. And what I want to do now, I want to ask questions. I want to ask questions based on the documents. How much money, how many orders do I have for Lisbon? How much money I made in Portugal? How much money I made for Southern Europe? How do you do something like that? One way to do that is to present things as multiple associations. What do I mean by that? We can have something like that. We have the notion of location. And we have Lisbon, Portugal, something like that. Another option may be to reverse this and do it like this. Whatever. It doesn't actually matter. Both of them are basically the same thing. Why are we recording? Why are we structuring the hierarchy in this manner? Well, I could do it something like this. As a single step operation. And then I have something like that. And it works. But notice the number. So if I'm going to work from here to get all of the associated hierarchy, what would I have to do? I have to traverse. And this is actually much worse if I want to go from Portugal to give me everything down the line. So here is something that I can do. In this case, I have a destination. Destination, that would be Lisbon. And that gives me a particular hierarchy for Lisbon, which is Lisbon, Portugal, Southern Europe. Notice what I'm doing here. This is a FANAP MapReduce. I'm going to emit the amount for each one of my parents based on this hierarchy. And the end, I'm going to aggregate that based on each one of those results and get this. So this is a really nice way to very cheaply be able to say, oh, show me everything in South of Europe. It would give me just pre-digested. Let's do it to Portugal. Let's drill down. Let's drill down. Every time I already have this data ready and really able to operate. This makes things a lot easier. Which leads to another interesting observation. In a relational database, in many cases, you have this notion of configuration, key values, something like that. With RavenDB, we actively discourage that approach. I don't want you to store mapping of A to B. No, I want you to store the entire thing. You have a list of states. Don't give me one document per state. Give me all of the documents inside of a configuration states document. And the whole idea is that I have a very easy way of expressing complex systems. So here are some great examples. In particular, think about tax rates. Tax rates are different for food versus hygiene products to clothing to luxury cars. So I can encode all of that logic inside the one document and throw that into as a configuration document, and then do locus upon that. And some other example, one thing that I want to be very clear about, for things like organizational hierarchies or tax rates, we have to be wary of changes. What happened when the tax rate has changed? What am I going to do now? We talk about this more in just a bit, but I want you to keep that in. So here's some basic rules for document size and the way that you should think about it. A document should have meaning. You should be able to pick it up and read it on its own. In terms of size, I like to say that a document should be the kilobytes range. If it's 2 kilobytes or 200 kilobytes, it's okay. If it's 2000 kilobytes, yeah, no worries. If you start counting that in megabytes, what is it that you're doing? Probably need to split it. Not for RavenDB sake, just because operating something this big means that you have to schlep it around all the time. No one wants to read it all. It's like, oh, I give you the entire encyclopedia all in one shot. These are the rules that I came up with for document modeling. They are from the Inside RavenDB book. And you can see that a document should be independent. It has its own separate existence. It should be isolated. I can change that without also modifying other things in the system. I may absolutely want to modify multiple documents at the same time, but I should be able to go into a particular document, modify that, and operate on that. It should be coherent. Coherent is an interesting term. It means that I should be able to look into that and operate and make sense without looking into other things as well. And okay. So I mentioned what happened when tax rate change. Well, that's an interesting discussion. There are many, many scenarios where we work with what is called temporal data. Data that is relevant, not only what is its value, but what was the value for this item at a particular period in time. Let's think about some common examples. Payroll. On January, I pay Steve $200 based on a rate of $25 an hour. In February, Steve got $150 on a rate of $29 an hour. So how would you approach something like this? How you model this? And there is a whole world of complexity in payroll specifically. But the answer for document-based systems is that, oh, this is quite simple. You have the notion of Steve/payroll, contract, latest. This. So, or maybe January. So this is the contract for the rate for Steve in January 22. And this is the rate for the current one. Notice that they are distinctly different from one another. Why does it matter? Because now I can do a couple of really interesting things. I can go and say, hey, Steve just had me a timesheet from January. I need to compute his salary as of that time frame. With this model, this is trivial. At one company I worked for, they managed to mess up a scheduled job. There was a nightly run that would update the VAT value. And there was some mess up with permission, and that nightly run failed. This one has run, and now the VAT value was changed from 70% to 18%. And this ran for almost 6 weeks before people noticed that we were using the wrong VAT value. And that was literally 1% of all total sales lost because we charge less VAT than we should have, so the company had to eat the cost. This was not a nice thing to do. Now, in case of taxes, I mentioned here that you have to be aware of changes. So given what we know, how do we manage that? We're going to do this. So this is the tax rate for that particular time frame. And in the order document, I am going to have this. So if I need to recompute this, I can do that with the data as it was at that time frame. And we have a question from someone with Cyrillic characters that I cannot read. I ask you to unmute. If you have a question, I'll be very happy to answer what you have to say. To the person who is raising their hands, I assume that you intended to do that. Okay, I think that that might have been an accident. We move forward. So the whole idea with how you deal with temporal data with documents is that you make a copy of the data as of that time. It sounds like, what, copy, and what about the whole concept of third normal form, etc. That's the whole point. I don't want that to change. I want to present a snapshot of how that value was at a particular point in time. And remember, RavenDB has features specifically meant for that. Things like documents compression can reduce the database size by 2/3. I had a database that went from 150 gigabyte to being 57 gigabyte. So storing the duplicate data doesn't actually cost me that much. But it gives me a lot of flexibility to operate. So, best model advice that I ever heard is to use the fax, which sounds absolutely ridiculous, right? But think about the things that I've been saying throughout this presentation. I've showed almost no code. I went into no major details about how things are going, but I use terms such as purchasing request, supply manifest, those sort of things. Those are physical documents because the problem that we're trying to solve isn't new. It has been solved using pen and paper. including all of the details such as concurrency, such as business rule validation, those sort of things. This also has a great simplification from our perspective because there is one-to-one mapping to the business. So I can go talk to a business analyst or to the owner directly of a particular feature or behavior and don't have to run into the impedance mismatch. I can take advantage of the fact that I'm running in a digital world. I don't have to be constrained by it. You can see it's one-to-one between the physical paperwork and how I represent things on my database, because that's how the business works. And we have a question from Jamie Tain. How do you update the data across multiple tables? So I would love to have clarification on what you mean with regards to this. The actual scenario is that, well, RavenDB can run a transaction across multiple documents, including multiple documents belonging to different collections. The question here, under what scenario does it make sense to do that? Now, there are, in the context of the big orders, it absolutely makes sense to have a big transaction to do that. For example, when I want to take all of the data, all of the purchase requests for a particular customer and move that from open to in processing. So you cannot add more items to a purchase request that is currently being processed. You may also generate the shipping manifests at this time. So you're working with multiple tables and you just do that. There isn't anything that limits you or hinders you from doing that. We have a question on, again, from Jamie. For example, the tax rate changes. Where do we put the new tax rate? Say the user changed their address to update the do we update the historical documents? And that is an excellent question. And the answer is that I really hope you don't do that. Let me explain why. We have an invoice. The invoice say, let's say Lisbon for 200 euro. The tax rate in question is this thing. Now, the user now move. They move to Morocco. Different rules. What change am I making to my data? Think about that. I issued you an invoice. At the time that I issued an invoice, you were living in Lisbon. Therefore, Lisbon rules apply, Lisbon tax rate apply. The fact that then you move to Morocco does not change the fact that the invoice was issued on Lisbon. It's easier to think about it if we add 10 years in the middle. If I issued you an invoice and 10 years later, you moved, do I go back 10 years and fix that? Of course not. This is not a live data. This is now historical record that you do not modify. Think about it. The Portugal government is coming to you and says, where is my VAT money? And you're going to say, what? And you modify the order, therefore you're missing a VAT payment. Why is that? It gets more interesting when you realize that there is a distinction between current and historical. A current document, so until I actually generated the invoice, I may change the shipment location and therefore change all of the tax rules associated with that, etc. But once I pull the trigger on the order and generated the invoice, it's now immutable. Now, if I'm talking to the accountant and I'm going to tell them, hey, I issue an invoice for 200 euro, for 400 euro. This is a mistake. I meant 400 euro. What do? We actually had this scenario at my company, and we issue an invoice using the wrong currency, and we fix that. We update the invoice to say, hey, this is not 400 euros, this is 400 dollars. And we were audited on that. We were audited. And that came up as something in the audit. And basically told us, you do not do that. What you actually have to do is you issue a credit invoice, canceling the amount, and invoice a new one. So you do not modify historical documents. You may issue a new document, a new value that would cancel the effect, but you still have that record in your system. Pavel is asking, how do you modify data if it actually changes? As it is part of the natural key users indices. Think about what I just said, Pavel, and the impact on that. The kind of natural keys that I'm using, things like that, they don't actually change. If I have a contract with you that started in January of 22, I don't have the ability to change that contract. I have the ability to enter a new contract with you, which means that I would mark this as closed and have a new one as of August. All new operations go here. Now, be aware I'm modeling here something quite complex. Payroll and billing and temporal data is not for the, it's not a trivial deal, it's not a trivial deal at all. But the whole point of this webinar is to give you interesting information, not repeat on let's do another login form. Okay. Now we have to make a distinction between current information and historical information. In some cases, we actually need to make a distinction between them. Contracts is a great example. Payroll is a great example of that. Here's another question. Jamie is asking, in a scheduling database, there might be a free time, maybe for a haircutter. There are 3 barbers and 2 pedicurists. People are looking for slot 2 months in advance. How do we handle that kind of thing? Okay, so scheduling. This is a fascinating field because the way that you typically do that is you look for the absence of information. So I want to find a free slot where free slot is defined by there isn't an existing appointment on that time frame. And the answer is that if you try to do something like that, I wish you all the best. Please shoot yourself in the head, it will be less painful. I will explain why. Scheduling sucks. Absolutely, fantastically sucks. Why? You have business hours, which are modified by calendars, such as holidays. There are things like strikes. So basically, I can't tell you, I can give you a template. There's something called a template, scheduling template. And the scheduling template says something like that. Monday to Friday, this is the schedule template. And here's what happened. Here's what I want to do. I'm applying the template to a calendar. And I'm creating, and let's say that my slots are 30 minutes in length. And I'm applying the template to calendar. So it would know, do not create slots on bank holidays. Skip I know that there is, I don't know, There is a parade in the town, so my shop is going to be closed. Those sort of things. And at that point, this turns the system, instead of searching for absence, search for existence. Give me all of the slots. It's basically from slots where location equal loc and date something like that. And that makes the scenario so much easier. When you registered to the webinar, there was some you asked if you had any questions, and I got some really interesting ones. So here are some questions that I got in advance. If you have any more questions, please feel free to ask them. I will get to them shortly. So the first one is access control. And users have different roles on per some business role. Manager for client A, read only for client B, or something like that. And the question is, how do you manage that? And this is interesting. And the example I like to always give is this one. Vacation request. Because employee may create, update, and submit it. Manager may approve or decline. Those are the valid operations. If you translate that into database operations, well, this is edit, and this is edit. What gives? Both scenarios are basically the same thing from the perspective of the database. Modify the same document. The difference is the business rule that you manage. And for that, in many cases, RavenDB say that the application that uses RavenDB is the one to give the context of meaning to that. So you have to give us some idea about what you want. And basically what I'm saying here is that for something like this, you write the code to do that, because otherwise there is no way that we can distinguish between those operations. The Java SDK hand coding the RQL in reusable generic way, translated from Cloud Studio. In the Java SDK, you have this option. Something like that, if I remember properly. And that's the way that you would do this. Lookups or types of, and how do I use in NoSQL? This is mostly, I think, about configuration documents, countries, those sort of things, and I think that I already discussed it here. Orders and customer balance and operations in a domain-driven design and align with document modelization. So I think that I cover some of that in this webinar. The concept, by the way, in this case would be to say, okay, in the case of a supermarket and a food provider, then you always have outgoing shipments and monthly invoices, and they should supposed to balance themselves out eventually. But basically, you just run the charge total and the income total and see that they don't go too far from one another, given what you have. A lot of that is dependent on how do you actually compute your charges, there's a term for that in accounting, which I can't recall right now in English, which is the debts owed to you and the credit that you give. But the basic idea is that you basically fall down into accounting practices and say, okay, here are all of the charges that I have for this month or this quarter, here are all of the income that I made that is assigned to that particular quarter, and does it zero out or not, and that's about it. using RavenDB to publish and distribute product release on pipeline, but from separate into release channels. If you're here listening, I would love to understand more about what this question is. I didn't know about that. Modeling one collection with many properties or separate them. I think I answered that, but I wanted to pinpoint the issue here. The issue is, are you talking about here something that has one reason to change or multiple? If this is multiple changes, use multiple documents. If this is just a singular one, then you want to have a single document. Now, sometimes there is a reason to use physical document separation. If you have the possibility that, oh, I may have a long history on this document. And the example that I typically give is auction and bids. I may want to have many, many bids on an auction, and I may want to have a history of them, but I don't want to keep them all in the auctions document. So what I would do at this point is something like that. And now I have the bids, and I have 10 latest bids. And here are the older bids. So I create a physical separation between them just to manage the size and the scope. A B2B sales process to chat interface. I would love to know more about what was asked here. A cluster environment, advanced search query, and using advanced techniques for complex queries. Again, I need more information. I would love to be talking about these sort of things, but I need more concrete examples so I can not just spout the usual thing that I usually do. And transaction management in document database. I mentioned this here specifically because RavenDB is a transactional database. It is meant to run in OLTP scenarios. So it's very well fitted, and there's nothing really that you need to do to handle that. And now let's answer your questions. So Pavel is asking, sorry, maybe that's not the case for RavenDB, but imagine we have a product. Today, the category we belong to is home goods, later another, etc. And then we need historical data, how much we earn from a category. This category is now named differently, but it had 1,000 names historically. From my point of view, it would be impossible to gather and separate such data as what income from product in this category 10 years ago, aggregate all its old name. Well, that's an interesting issue, and we have to consider what does it mean. To start with, there is the notion of product, and a product has a category, something like that. Now, depending on your needs, you may want to do this as well. Why does it matter? Well, if I want to create a strict separance between the category name and the category ID, that's one thing. In that case, I want to be able to change the category ID, but not to change the category name for this product. Probably not a good example for products and categories, but we go with that. The common example, by the way, is pay stub. I now issued, and let's say, this is a pay stub for Rachel Green for December 99. Now, in 2005, we have this. What should show up here? For a pay stub, this is easy. Show the name as it was at that time frame. For a product, you want to show me the current name. So the issue, so that's why you may want to store the name or just the ID. If you store just the ID, well, that's it. in your case, Pavel, I think that the issue is whatever you actually are interested in tracking the changes of product across categories, or I just want it across this category. I don't care what it's called now. And again, the whole idea is whatever I'm storing by the ID or by the name. Gingrich, I'm sorry if I'm murdering the pronunciation. How will you model and query for getting table with rolling sum in, let's say, expense income overview? That's an interesting question because what's the scope of that? In all honesty, if I'm running something like a ledger, so I have a daily or monthly statements, and then that is just values inside the document. I would probably not, they're not even stored, they're just computed. And I would model it like that. If you're talking about, because typically rolling sum is something that you would want to do for display, not for operations. So maybe I'm not quite understanding that. Another question from Gingrich. Would you have any hint on when to think about splitting data into multiple domains and databases? Hint is about the only thing that I can do. You want to split it into different domains different domains in the context of domain-driven design when there is a shift in the thinking. Going to the domain-driven design, there is the notion of at some point in the system, I'm thinking about the legal responsibilities of the cargo. In another point of the system, I'm thinking about the routing of the cargo in the most efficient way and something like that. Both cases, I'm actually thinking about shipping. In one case, I'm focusing on the legal ownership, insurance, freeing from the tax and all of the import duties, whatever that you have to pay. On the other side, I'm talking about put it on a crate, put it on a truck, on a ship and ship it. So even though logically both of them are shipping, they have very different concerns. So that would be the first thing that I would look at. There's also a lot of guidance around microservices and how you handle that. Beware from making things too small, because then just the orchestration overhead is going to be quite painful for you. We have a question from Vit. How would you go about tracking user presence owner status? User can be connected from multiple devices at once. So we'd like to know about every connection, device type connected at. So that would be a document user connection. Then I can have a separate document for user online status. So I don't have to query user connection every time that I want to know user online status. But does this document really make sense on its own? I could also put inside user and patch user by when he connects to these parts. Well, this is the sort of things that RavenDB has an explicit support for. We have the notion of time series. And I'm going to use a time series that says connection status. And this is from phone. And now I'm going to say, so this time it is connected from the phone. And every minute, therefore, I'm going to omit this sort of thing. And this is a time series value. You can see here, this is a slightly more interesting one. You can see that I have tag, where in this case, where this value came from. In the case of connection status, this is from here. And browser. So now each one of those is going to meet every minute, every whatever. And in order to see when whatever user is connected or not, you're asking a question like this. So now you can see what was the last value, and there should be a way to say, there we go. So now you can see that this is the last time that this user was connected. You can even see from how many locations it was connected, etc. And it's just easy to do it this way. If you don't emit the event every minute, then that's the gun-outer that you have, and then it's not connected, or however you want to make that. Gennady is asking or saying, Java SDK was a comment, not so much a question. We already use our query, but the syntax that we can do without the Cloud Studio isn't always easily used or translated. For example, I want to have RavenDB controller generic insert, so I can pass a query that contains a map of parameters for dynamic nature. Oh, I think that really? Here we go. So you can do it like that, and that is more easily copy-pasted between locations. Notice that we explicitly don't have a query format for generic insert, so I'm not sure what you mean. But but to be able to work with parameters in the studio, you do it like this, as simple as that. There's now a question: how can we do a dynamic way of only updating a part of a document, especially when there is a hierarchy and then we want to modify just a field in that hierarchy that may be 2 levels down? So in order to handle that, let me see if I have something easily available. We have the notion of patching, which I don't have an example here. We'll use this example. Let's look at orders. And I want to, let's say, modify this discount. So I could do something like that. And now we'll be able to see. You can see 0 discount here. And here is the discount here. There is also a way to do that through the API. And you actually have multiple ways of doing that. Okay. So this is JSON patch, and we want to look at Java. Okay. So there's the JSON patch option. And I think this is for the C# still. There's the JSON patch option that you can use to send to RavenDB, and it does something like that. And there is also a here, single document patch operation. That's what I care about. Okay, patch. Okay. You are using Java, so it would look something like this. You have the ability to do a defer, and the defer allow you to send a patch command data. The patch command data allows you to send this logic for particular documents. You can basically run JavaScript on that document and operate in this manner. Also from Gennady, sorry, these are more general comments, questions. Not not so much for the document design webinar. Would appreciate the example documentation that seem more C# focused to be improved and made more equivalent for Java. Yes, that's something that we have is an ongoing process. As you can imagine, we have quite a lot of documentation that takes time, but feel free to go to here. The discussion board and ask any all of your questions. In general, we are trying very hard to provide good community support, and once we notice a lack in some locations about the documentation of languages, we will certainly speed it up to fix that. And with that, I would like to thank you very much for sharing for this webinar. I really like it when I have this level of interaction with people. Thank you and have a great day. Goodbye.